Balai sir, can we start the program?
Yes, sir.
Am I audible, Acharya?
Sir, very clear, sir. Your voice is very clear and it is audible, sir.
Okay, right. Thank you.
Sir, we are eagerly waiting for your lecture, sir.
Yes. What is the and yes, right. Go ahead.
Sir, yes, sir. Good evening to all participants. On the occasion of 137th birth anniversary celebrations of Sri Srinivasa Ramanujan, our department is conducting a one-week online international workshop on mathematics, bridging ideas and innovations MBII 2024 from 16th to 21st December 2024. On the first day, that is 16th December 2024, Dr. L. Jagannathan Sir, Professor, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai, delivered a talk on mathematics of machine learning. On the second day, that is 17th December 2024, Sri NVRD Kumar Garu, Senior Faculty, Department of General Education, Skyline University College, Sharjah, United Arab Emirates, delivered a talk on lifelong learning in the era of AI. On the third day, that is 18th December 2024, Dr. T.S.R. Murthy Garu, Professor, Department of Mathematics, Sri Vishnu Engineering College for Women, Bhimavaram, delivered a talk on some aspects of statistical hypothesis verification. Yesterday, Dr. P. Nagarani Madam, Associate Professor, Department of Mathematics, the University of West Indies, Mona Campus, Jamaica, West Indies, delivered a talk on numerical methods for engineers and scientists. A good number of participants attended yesterday's session. Thank you one and all for your valuable participation in yesterday's session. Now, I request our beloved head of the department, Dr. KVL Acharyalu Garu, to address the gathering for today's session.
Good evening to all. Respected eminent resource person, Dr. M.A. Srinivas Garu, my esteemed faculty members and my dear students. On behalf of Department of Mathematics, I humbly welcome all of you to this fifth day of our international online workshop. As head of the Department of Mathematics and the convener of this international workshop, I am deeply honored to have this opportunity to speak a few words in today's session of international workshop, which is being conducting in view of 137th birth anniversary celebrations of Sri Srinivasa Ramanujan, who is applauded as one of the greatest mathematicians in the world. This workshop is being planned so that students can improve their computational abilities in their engineering fields. The primary objective of conducting this international workshop is to focus on enhancing the computational skills in student community in various fields of engineering. BTech students can build strong computational skills necessary for future success in their chosen disciplines by integrating academic knowledge with practical applications by dealing with real-world challenges. In this connection, all BTech students are advised to improve their computing skills. Our esteemed resource persons can provide insights in which computational skills are utilized in real-life situations, encouraging and motivating our students to enhance their inherent abilities in computing. So, with your worthwhile participation and collaborative cooperation, this program will be a fruitful one undoubtedly. Today, we have a wonderful resource person with us. The resource person for today's section is Dr. M.A. Srinivas Garu, Professor Emeritus, Department of Mathematics, JN2 University College of Engineering, Science and Technology, Hyderabad. Dr. M.A. Srinivas Sir is not only an inspiring teacher, but also a source of motivation, guidance, and unconditional support to the students' community. All through his career, Dr. M.A. Srinivas Garu inspired thousands of students and also faculty members and won fame as a best teacher. Since all of these, I can say that he is the best role model to all of us. On behalf of Department of Mathematics, I express my sincere thanks to Dr. M.A. Srinivas Sir for graciously accepting our request to deliver his valuable lecture in our international workshop. Thank you, sir. Thank you very much for your kind consent. Finally, I strongly believe that all our participants can definitely utilize this opportunity to improve their computing skills in mathematics. All the best. Thank you. Thank you, one and all.
Thank you very much, sir, for your valuable message. Today is the 5th day in our 1-week online international workshop. Today's speaker is Dr. M.A.S. Srinivas Garu, Professor Emeritus, Department of Mathematics, JNTU College of Engineering, Science and Technology, Hyderabad. Now, I request one of our staff organizers, Srimati K. Nagamani Madam, to present profound profile of Dr. M.A.S. Srinivas Sir.
Good evening all. Welcome you all. It's my privilege to introduce today's resource person, Dr. M.A.S. Srinivas Garu. Dr. M.A.S. Srinivas Garu is a professor emeritus JNTU College of Engineering, Science and Technology, Hyderabad. He did PhD with the thesis entitled Contributions to Certain Non-Linear Biomathematical Models. He was a postdoctoral fellow at International Center for Theoretical Physics. He supervised and completed 8 PhDs, and currently 3 students are working for their PhD under his guidance. He published 50 research articles in various reputed national and international journals. His areas of research and mathematical modeling of biological systems, boundary value problems, and fluid dynamics. He has completed 4 research projects funded by UGC and TechWip. He published 4 textbooks in mathematics and statistics, and 2 more books are in pipeline. He adapted modern teaching methods for visualizing theoretical concepts and created animations on topics like Fourier series, applications of integration, eigenvalues and eigenvectors, and basic concepts of calculus which enhance the teaching learning process. He delivered a lecture on multiple integrals which was webcasted to affiliated college of JNTU Hyderabad, and also delivered another lecture on partial differentiation which was telecasted by Doordarshan Adagiri channel, and both of these are available in YouTube. He is a life member of various professional societies and a member of several academic committees. He organized several conferences, workshops, and faculty development programs. He received National Merit Scholarship during 1983-85. He rendered his services academic senate member of Andhra University. He was nominated as a panel member for AP Mass Forum formed by Raju Vidya Mission, Government of AP in 2010. Dr. M.A.S. Srinivas Sir is appreciated by one and all with his best way of teaching for the last 3 decades. His contributions to the department and the JNTU Hyderabad in various roles are remarkable. His helping nature, inspiring character, advanced teaching methods with visualized research capabilities are additional qualities in him apart from his goodness and vast experience in the field of education. Thank you all.
Thank you, Srimati Nagamani Madam, for your nice introduction about Dr. M.A.S. Srinivas Sir. Now, I hand over the session to Dr. M.A.S. Srinivas Sir. Sir, please.
Yeah. Thank you very much for your good words. Let me share my screen. Is it visible to you now?
Yes, sir. It is visible, sir.
From the last 3 days, all the participants were exposed to several concepts like artificial intelligence, network securities, and some other things, and numerical methods and all. So all those things are very advanced things. But probably my lecture may be different from those. I don't want to concentrate much on the advanced topics. The reason being, once you want to have some kind of exposure towards the advanced topics, one has to have some basic knowledge. Simultaneously, everyone has to equip themselves with some kind of skills, how to apply the basic ideas what you have to those advanced topics. So probably my lecture today will focus on those things. So my compliments to the distinguished teachers and students who are present there. As all of you know, this mathematics is not a subject which was recently developed. It is from the very, very ancient days. It was there. It is the most ancient of all the sciences, and it was there since ages, and still it is alive also. It is a living science, and the living science is not in a passive mode. It is in a dynamic mode, and it is stimulating many more applications in several domains. Whatever domain you name, in that domain, the mathematics will have his place to record. And no science has its vocabulary without the mathematical formulations. Without using mathematics, nobody can talk about physics, nobody can talk about chemistry, nobody can talk about the technology, nobody talk about the whatever you, even linguistics. Nowadays we are using all this in mobile phones. We are using everything in our own regional languages. The reason for that is the mathematics. Not only for all the branches, for engineering, science, pharmaceutical sciences, botany, zoology, medicine, anthropology, economics, history, in everywhere the mathematics is there. And mathematics is the only language shared by human beings regardless of culture, religion or gender. Wherever you go on the earth, if you want to say that two numbers are added, everybody uses the symbol plus what we write. Everywhere the addition will be represented by that. The language of mathematics is same wherever you go throughout the world. And first of all, I would like to congratulate all the members who are organizing this international workshop. Really, I'm very happy by seeing that title what they have given, Mathematics, Bridging Ideas and Innovations. Yes, mathematics is a bridge for any two subjects what you take. If you want to convert, for example, if you want to link a physics with biology, mathematics is required. If you want to link something in one subject to another subject, that link is the mathematics. So definitely the mathematics is an excellent bridge. So that's why after seeing that title, I felt very happy. Mathematics serves as a bridge connecting abstract ideas with practical innovations. Not only it connects two different subjects, it also connects some ideas, whatever you have, in bringing up those mathematical ideas towards the innovations. The main advantage for using mathematics is it has a precise structure, and it fits in a very logical framework, and most importantly, it will give some fuel advancements in science, engineering, technology, and whatever you see. Mathematics has fueled advancements inside. Whatever advancement you have in any branch of science, any branch of engineering, any branch of technology, so this mathematics plays a role. The beauty of mathematics is that it always plays a dual role. Dual role in the sense, mathematics itself develops, that means so many mathematical theories will be developed. That is what abstract ideas. Theoretical mathematics explores pure concepts. For example, many of you know number theory, abstract algebra, topology, all these things. So many kinds of mathematical theories were developed, and they are simply a mathematical theories only in olden days. But because those abstract subjects, they themselves has created some kind of interest for the people to apply those things. So simultaneously the mathematics will be used to in some kind of applications. It has some concrete applications. For example, if you take number theory, that number theory has breakthrough applications in cryptography. If you take abstract algebra, the quantum computing, what you are talking about nowadays, that abstract algebra plays a major role. That will be used very extensively. And if you want to talk about robotics and motion planning, that is topology plays a major role. For instance, as I already mentioned, for example, if you take one topic, differential equations, this will bridge the biology and physics, but thereby we have one subject called biomechanics. If you want to study biomechanics, you need to know some biology, you need to know some physics. So for that, the mathematics is required. Mostly differential equations plays a major role. And mathematics helps innovation by offering tools to solve real world problems. So for example, cryptography, if you take, it will have so many modern encryption methods and digital communication using advanced mathematical algorithms. All these things will be studied. And probably in the previous lectures, I don't know, the other resource persons might have used these topics while explaining these cryptography, in artificial intelligence, you will have linear algebra, calculus, and probability, etc. And so many algorithms. Because when artificial intelligence, if you have, there will be circumstances where you need to deal with so much of data, how to deal with all those things, and we need this linear algebra. And also another most important, more prominent field is space exploration. Orbital mechanics and numerical methods allow spacecraft to reach other planets. If you want to move from one planet to another planet, there you need to know this mechanics, orbital mechanics, and for doing those things, the numerical methods also plays a major role. Like this, the mathematics is critical for emerging technologies. Nowadays, quantum computing, renewable energy, big data analytics, these are all nowadays very emerging technologies. To have advancement in these technologies, we need so much of mathematics. Okay, that's fine. Windarki chala excellent ga undi. Like, okay, our mathematics is being used at several places in the universe. Very advanced technologies are being used by the mathematics is much more helpful in getting those advancements. Everything is fine, but how to have this strong bridge? That bridge is the mathematics. How to have this strong bridge? How to make that bridge strong? Probably my lecture will focus on this, to make this bridge more stronger. If you want to break that bridge more stronger, you need to have basic knowledge, and you need to have proper understanding of the concepts, and need to have applying these theoretical concepts to practical problems. So these ideas, all of a sudden, nobody will give you. There will not be a separate theory. From the beginning itself, you need to learn those things. Because the audience here mostly are from the engineering students. I thought instead of giving a talk on, say, one particular topic, so why don't I give you some inputs to the students, how best they can learn mathematics, what are the basic characteristics one has to develop in learning mathematics properly. If you learn mathematics properly, probably that will be the best bridge between two areas, whatever in your engineering, whatever you want to study. If you want to link up your, say, computer science with biology, there also this mathematics is required. If somebody who is doing mechanical engineering, if they want to link up that mechanical engineering with something else, then mathematics is required. So these are the students should be equipped with them with the following skills. Anyway, this is good listening skill that is not only for learning mathematics, for everywhere. If you want to become a good student, or if you want to become a good citizen of India, if you want to become a good personality, then one should have the good listening skills. listen to the others what they are saying, either maybe parents or teachers. First listen properly. Once you listen properly, Sumati Setkallo kuda undi okati vinadagu nevaru cheppina. I think listen that and take whatever it is possible best and take it. First listen to them. And most importantly, in mathematics, one should not pre-assume anything unless it is a valid thing. These two. And one more thing is you should have logical reasoning. I'm especially for the computer science students, this logical reasoning plays a very, very crucial role. Your logical thinking only give you a better, I think you will be in a better position in your coding if you are good at logical thinking. If you are very good logically, if you think, you can prepare your codes with less number. You can have the better algorithms. You can write your programs very well with minimum number of lines in coding, and all those things will happen only if you have that logical reasoning. And gate, NOR gate, all those things are also very much required. And also analytic. If you want to understand anything, you need to analyze the things and then try to understand. Okay, if while reading any of some of your some theories, if you have one method, if you learn, and do you have any other method to solve that problem? Learn as many methods as possible to solve a particular problem, and if by doing so frequently, you will automatically you will get one idea what is the best method. Sometimes though the method is very laborious and very difficult, but it will have better implications. So always try to search for all the alternative methods with which we can solve a problem. If your teacher solves a problem by using one method in the class, after going home, try to solve the same problem by another method. Applying the theory to practical problems. So how to apply the theory to a practical problem? And for having better understanding, we should have the visualization of the concept. Simply by hearting the formula and all those things is not good for learning mathematics. Remember this, my dear students, remember one thing. Mathematics is not simply solving problems and getting answers. If you are given an exercise in this, and if you apply the formula and if you get a result, after doing your problem, you go back to the textbook, and if you see the answer, if you get the answer, that is not learning maths. In each and every step, why you are doing that, why we cannot do in another way? If you can answer only such type of questions, then only it is what learning maths. Further, the visualization of the concept enhances your understanding of the things. So I'll give you a simple example of what actually a logical reasoning is. Probably though this question looks like some general question, this is actually can be done in using AND gate, NOR gate. I think you have any in logic theory, you will learn all the things. You can solve this problem mathematically also. Try to solve this problem mathematically, though it looks like a general thing. Suppose you are at a junction. At that junction, you have two roads, and one path leads to a village, and other path leads to some area, dangerous area, where one cannot go, where one should not go. At this junction, there are two persons. One person always says the truth. The other person always says a false, lies. He always lies. Now you have to ask only one person, only one question. You should not ask many questions. You should not ask many persons. Out of those two, you have to answer. I have to ask only one person, only one question. And you want to go to the village. Now, what question do you ask to go to the village? When what path is to be selected? That's what you want to know. Just I'll give you 1 minute time. If anybody is interested, try to answer that.
Sir, students are in mute mode to avoid the disturbance, sir.
Okay, that's
they
fine.
may give their answer in chat box maybe.
Okay, no problem. Okay, I'll give you. So there are two persons. Let us say A and B are the two persons, and he always says truth, and he always say lie, false. He always says. Now you have to ask one person, and what is that question to be asked, so that you have to know the right path to go. There are two ways. Here there are two persons, A and B, in which way this goes to village and this goes to some dangerous place. Now the question what we ask is, go to any person, no problem at all, and ask them, if I ask the other person, for example, if you ask this question any one of them, నేను విలేజ్కి వెళ్ళడానికి ఏ రూట్ అడిగితే రెండో వాడు నాకు ఏమని ఆన్సర్ చెప్తాడు అని ఎవరో ఒకరిని అడుగు. సో ఆస్క్, ఇఫ్ ఐ వాంట్ టు గో టు ద విలేజ్, what would be the answer given by the other person? You ask one person. Suppose if you put that question to A, what is that question you asked him? If I want to go to the village, what answer the B will give you? B will give me. That question you are asking A. Then what he says? A, what is the answer he will give? Because B always says the false answer, and because this is the way what you have to go to the village, this is what the person A knows, that this is the path to which that leads to the village. So definitely he will say that the other person B will give you this path. This is the information what he gives, because the other person always says false. If this is village, then he will give this as the answer. If I put the same question to B, what B says, B always says false, but B knows that A will definitely give the true. That means he will say, B will clearly know that A will give the answer, correct answer he will give. But because B always says false, he will say that A will give the answer which is leading to the dangerous place. In any case, both of them, whoever you ask, they will give that this is the dangerous path only they will show. If you ask this question, then automatically don't go in that path and go in other way. You will get the right path to go to the village. So this is what logic is. So these kind of things are much more required. So if you ask the truth, what is the other way? This I already explained. Like this, there are several examples. For example, if you take analytical reasoning, let us see this example too. I think many the students, many of you are aware of what is called binary system. So the example 2 is an application of binary system, but by reading that question, nobody, unless you have better idea, you will not say that it is an application of binary system. What different? Suppose you have, I will add this question also as one like story. Suppose there is one person who is very generous. In every month he will freely give some kind of oil to the persons whoever comes to his house. If somebody comes on 15th, he will give 15 liters. The number of liters he gives is simply exactly equal to the date of that day. Suppose if somebody goes on 30th of a particular month, he will give 30 liters of oil for him. If somebody goes on 1st of that month, he will give only 1 liter. But now the question is, to measure that different liters of oils, how many jars he should have and what are their capacities? That is the question to be answered. So here, if I'll again, this is 1 liter, 2 power 0 is 1, this is 2, this is 2 square, 2 power 2 cube, 2 cube is 8. If you have these three, then any number from 1 to 31 can be measured with this. Suppose if you want to measure, say, 15 liters, 2 cube, this gives you 8. And can you take 15? How do you make this 15? With the 1, 2, 4 and 8. 8 plus 4, 12, 12 plus 2, 14 plus 1, 15. Suppose if you want to give 16, Now with this 2 cube, he will measure 2 times. Like that, whatever number you take, that number will be represented in terms of 1, 2, 2 square and 2 cube, because 2 power 2 cube is 8. What is 2 power 4 is 16. That also requires here, of course. 2 power 4 also maybe have. 2 power 5, which is crosses 31. So no need of doing it. If somebody says in place of 1 to 31, if somebody says 1 to 63, then 2 power 5 also required. Therefore, the jars, number of jars required are 5, and their capacities are 1 liter jar, 2 liters jar, 2 square liters jar, 2 cube liters jar, and 2 power 4 liters jar. So this is what the similarly the first kind of there is one just I don't want to spend much time on it. I simply if you want to note down that question and do it later. You have 5 liters jug and 3 liters jug, and you need to measure exactly 4 liters of water. On the jugs there is no measuring markings are not there. Therefore, how do you get 4 liters of water or whatever it is using these 2 jugs? That is the question. And if you remember the qualities what I mentioned there, first, good listening skills. I think all of you are listening properly with my lecture. Second one is we should not pre-assume anything without having any proper reason. That is also more important. I can give you n examples for learning that. The simple examples I'll give you so that if anybody is interested, they can learn for that pre-assumption. Suppose if A and B are 2 matrices, what is A plus B whole square? Is it A square plus B square plus 2AB? If x and xyz are numbers, if xy is equal to xz implies y is equal to z. Is it correct? If your answer is yes, that means you are assuming that x is not equal to 0. You are assuming. Therefore, it is. I have not given you that xy is equal to xz implies y is equal to z. Is it true or false? If I ask, then we should say the answer only false. True is means it should be true every time. False means sometimes true, sometimes false. That should not be there. Therefore, xy is equal to xz implies y is equal to z is correct only when that x is not equal to 0. Without assuming this, if you say that is definitely a wrong answer. So don't assume such type of things. Very simple things. Similarly, if you have any another characteristic what one should develop is search for alternate methods to solve the problems. Suppose you have 1 plus 2 plus 3 plus etc. n is equal to n into n plus 1 by 2. So how do you how do you solve that problem? What are the methods do you know? Say for example, 1 plus 2 plus 3 plus etc. n is equal to n into n plus 1 by 2. So more probably majority of you may say the answer that it can be proved by mathematical induction, because the right side this n into n plus 1 by 2 is given. If only if I give you what is 1 plus 2 plus 3 plus etc. n is equal to how much, if I ask you, the other thing is, let us call it as s. The same s can be written in the reverse way, n minus 1 etc. 1. If you add it, it will be 2s. N into n plus 1 is n plus 1. N minus 1 plus 2, that is also n minus 1. Now you will have n minus 2 here, n minus 2 plus 3, that is also n plus 1. And the last one is also n plus 1. Therefore, there are n plus 1s are there. Therefore, n into n plus 1 is the right side sum. Therefore, s is equal to n into n plus 1 by 2. The same proof whatever we use for proving AP. These are the two proofs generally most of you know. Do you have any other method to solve it? That is the question. Now we can prove that result by another means also. So you take a rectangle of side n and n plus 1 units, divide that into two parts. I think everyone accepts that the part what I am writing here, this is this area and this area are equal. Now you just draw the lines. Yeah, here this is because it is 6 units divided into 6 parts. This area is 1, this area is 2, this area is 3, this is 4, this is 5. So 1 plus 2 plus 3 plus 5, that is this area. This area is also that, because 6 into 5 are the sides of this rectangle. Total area is 6 into 5, length into breadth. 1 plus 2 plus 3 plus 4 plus 5 is equal to 6 into 5 by 2. That is what geometrically we can prove that. So like this, we have several things we can prove anyway, because all of you are learned this Laplace transform method. Can anyone tell me how to find the Laplace transformation for it? Laplace transformation you can find for it by this, by using the basic definition, e power minus st into t square, e power minus sx into fx dx. I think you know from 0 to infinity, because it is divided in several intervals. So this is what, if you evaluate each and every integral and simplify, you will get the answer. That is no doubt. This is correct, 100% correct, the method 1. Do you know any other method? If teacher solves the problem by this method, don't simply always follow that. Try to find out another method. Do you have any idea on it? If you accept this, I think all of you know about the Heaviside function. If you write that function f of t, I can write it as first is t square times h of t plus, this is something like 5t minus 1 if I remember correctly, 5t minus 4 it seems, 5t minus 4 minus t square into h of t minus 1 plus, and the last one is t square minus 2 minus 5t minus 4 into h of t minus 2. If you write the function in this way, and you can use the basic one important result what you have, Laplace transformation of f of t minus a into h of t minus a is simply Laplace transformation of f of s multiplied by e power minus as. This we can use it, and you can using that you can solve this. That is another method. Just I am giving some examples which already you know, but this lecture simply will give you some idea how to solve these things. And the next thing is application of theory to practical problems. How do you apply if you know one theory, apply them to different kinds of problems. That is that kind of understanding, or that kind of what do you call learning methodology will definitely helps you a lot. Probably the mathematics teachers will give you several theories in your BTech, and after from third year onwards you need to apply them to your engineering problems. So you need to apply those theories. For applying that theory, one should know correctly the basic theory. If you don't know how to hold a screwdriver, you cannot unscrew anything. So first of all, you should learn that you should be thorough with the usage of that tool. Once you have once you have that skill of using that tool, you can use it wherever it is required. How best you can do it with that tool. So the tool is mathematics here. Once you have very strong understanding of these mathematical ideas, means you have very good skill on using this tool, then you can apply those things. Most of the times what happens is, especially for the engineering students, they will give least importance to the mathematics understanding. Of course, they will try to solve the problems and they will pass the examination. Passing the examination, getting the answers, and that is not learning math. What actually the concept is, concentrate more on the concept. If you have very good concept on any mathematical idea, easily you can apply this there. This is one example what I will give you. For example, in your multivariable calculus, in your engineering problem, maybe I don't know in your college whether it is there in the first year or second year, finding maxima, minima functions of two variables. There are two variables here, x plus y equal to k, and there is one function x power m into y power n, that is to be maximum. You can find out when it will have maximum value, when it will have minimum value. There are several things. One is x power m into y power n. Lagrange's method is there, some lambda times of x plus y minus k equal to, I am not going to teach that. But anyway, if you solve this theoretical problem, then the answer what you will get for that problem is x should be km by m plus n, y should be kn by m plus n. First understand very clearly what this result says. The result says this. Organizers, if any student puts any kind of message, then you can pass it on to me. I am not observing the message box.
Definitely, sir.
Yeah. So the theory says if you have two quantities, those two quantities, sum is always fixed. This is a variable, this is a variable, both are varying, but such that their sum is always fixed. The one quantity power m and another quantity power n, I want to make it maximum. So if this is a function of xy, find dou f by dou x, dou f by dou y equal to 0, find rt minus s square greater than 0, and all that basic things what you will solve it. Ultimately, you will come up with a solution like this. Km by m plus 1 is the x value to be taken. Y value should be kn by m plus n. If you take x value equal to this much, y value is equal to this much, then this x power m into y power n will be maximum. X is km by m plus n, y is kn by m plus n. From these two also, one should immediately, one thing should come to your mind. That means x is, this k is to be divided in the ratio m is to n. So this k is divided in the ratio m is to n, then automatically x power m and y power n will have the maximum value. So that is what this theory says. If you properly understand it, you can solve that problem. You can solve many problems based on that theoretical aspect. Find the dimensions of a sector of maximum area and of given perimeter. So here, for example, you have a sector here, and this is R here, this is L here. Find what are L and R such that this area is maximum. A perimeter is fixed. The perimeter means L plus 2R, that is fixed, means it is constant. He has given that L plus 2R is fixed. Now you want to make this area maximum. Area is of LR is the area of the sector. So L power is 1. Here you have two quantities. One is 2R, another is L. I am writing a half of L into 2R as 1/4 of L into 2R. 2R is one quantity I have. L also has one quantity. L power is 1, 2R power is 1, and those quantities sum is fixed, that is k. Now to have this maximum area, this k is to be divided in the ratio 1:1. 1 is power here, this 1 is power. 1:1 means that each should be k, half of it. L should be k by 2. 2R also should be k by 2. That means R should be k by 4. So these are the value, these are the dimensions of that sector. If you take radius of that sector as k by 4, arc length as k by 2, automatically that sector will have the maximum area. Similarly, the second question. Let us see the third one. The equation of the line forming minimum area here. This is one important thing is here he is asking for minimum, but here in In the theory, we learned for a maximum. How do you correlate those two? That is one important aspect. So this is what so here you have a fixed line. Say he has given that 3, 4. Through 3, 4, you can draw n number of lines. More number of lines you can draw. Every line will form one triangle. Out of these triangles, which triangle will give you the minimum area? That is the question. So that area should be minimum. So if this point is 3 by 4, whenever the line is changing means if the x-intercept and y-intercept are changing. So let the line be x by a plus y by b is equal to 1. If line changes, this a and b are my variables. Those are changing. But this every line is passing to 3 by 3 and 4. So 3 by a plus 4 by b for me is always 1. So this is one condition. Now what is the area of this triangle? Area of the triangle is half of x-intercept into y-intercept. Half AB is the area of the sector. So if half AB is the area of the sector, he is not asking minimum area, he is asking. Now this half AB, I am writing it as this half of AB, I am writing it as reciprocal. This is to be maximized. For maximization of this, I know the formula, I know the rule. Now, if half AB is maximized, then 2 by AB will be minimized. Reciprocal of that will be minimized. The 2 by AB, I am writing it as 3 by A and 4 by B and 1/6 of it. I can write like this, 2A by B. Now I have two quantities, 3 by A and 4 by B, whose powers are 1 and whose sum is 1. So that 3 by A should be, value should be 1:1 ratio, division of that 1, therefore it should be 1 by 2. 4 by B also 1 by 2. That means B should be 8 and A should be 6. Therefore that line is x by 6 plus y by 8 equal to 1. The same problem can be solved in another way also. There are so many methods, but the thing is, you need to know what best we can do it. If you see another problem, the maximum value of sine cube x and cos power 5x, if you find the derivative for it and if you do that problem, it takes a lot of time. I mean, a lot of calculations and all those things are required. Sine cube x into cos power 5 is required. I'll simply give the idea, I don't solve that problem. How to use this technique there. The question is how to minimize, how to maximize the sine cube x into cos power 5x. This is to be maximized. So I know one rule. That rule is sine square x plus cos square x is equal to 1. If I have two quantities whose sum is always fixed, sine cube x I will write it as sine square x whole power 3 by 2. This is cos square x whole power 5 by 2. That's just some simply. The problem is solved. So there are two quantities whose sum is always 1. Those quantities powers are there. What are those powers? 3 by 2 and 5 by 2 are there. The ratio is simply 3:5 only. Divide this one in the ratio 3:5. Therefore, that sine square x should be some 3 by 8. Cos square x should be 5 by 8. Tan square x should be 3 by 5. Tan x should be root 3 by 5. X should be tan inverse 3 by 5. In this, if I put x is equal to tan inverse root 3 by 5, you will get the maximum value or minimum value. This is what very interesting things. Once you know theory, how to use that theory to apply to different practical problems. Like here, one trigonometry we used, one geometry we used, and another calculus. So many things are there. So all this already explained. Now the last topic is, so far we have learned what is a good listening skills that one should have. And secondly, you should not pre-assume anything. If time permits, for pre-assumption of things, I will give you a very interesting story. If time permits, at the end, if anybody asks, I'll give you that interesting story. and after that logical reasoning is one thing, and also analytically you need to think and also apply different theoretical aspects what you learned to the different what do you call any theory to different practical problems. And after that, the most importantly, theoretically you can solve so many things, but you can learn so many things. For example, you learned Fourier series, you learned from the beginning of functions you learned, and say logarithms you learned. They like that, so many concepts from the beginning in mathematics you are learning. What is the advantage of logarithms? And the inverse function is there. How do you find the inverse function? And what Fourier series, already if a function is given, you are finding the Fourier series. And you know several expansions like e power x, cos x, sin x, tan x, all these things. And in physics also you will use very frequently when x is very small, sin x is equal to x. What all these things in fact means, how to visualize them, how can we understand those concepts very clearly. Though when x is very small, sin x is equal to x can be understood simply because when x is to 0, you will get 0. If you see the graph of sin x, you will understand it. But having a better understanding of the things, this visualization of the mathematical concepts are very, very, very important. For example, if I ask you to sit at a cinema theater gate outside the cinema exit, and if I allow you to listen entire all the dialogues, songs, etc., and after listening that, do you understand that movie completely? Definitely not. Or otherwise, in other way, I will allow you to sit inside the cinema theater. I will mute completely. I will show you only the motion of the pictures without having any dialogue, without listening anything. Do you understand that? No, not at all. So if both of them are correlated, then you can understand what actually is happening there. You can enjoy the things. You can understand very easily. So visualization is only makes you understand more clearly. So visualization not only usually everywhere in mathematics also, visualization of mathematical concepts are very, very, very important. And that too, because of the advancement in technology, nowadays we have excellent tools for making our own visualizations. So that the understanding of mathematics can be made very easily if we use those technologies. Try to a request to the teachers is try to incorporate some kind of technologies to show the students the different kinds of visualization may be have a dynamic in nature, maybe static pictures, anything. So that and I, in my experience, I saw so many teachers who teaches mathematics in the class without drawing even a single graph. So the main basic idea of a teacher is to draw as much graphs as possible. You draw the graphs. For example, we teach, say for a Laplace transformation, shifting property is there. Just show that as an using a graphically, so that they will understand what actually the shifting property tells you. So all of you know that visualization is something which is maybe image or a diagram or an animation to communicate some message. That is what visualization is. And great fun in visualization is that it gives you answers to the questions you don't know what you had. In mathematics, if you see some kind of visualizations, after seeing that visualization, sometimes what impression do you get is, prior to this, you seeing that visualization, you didn't know that question you had in your mind. After seeing your visualization, automatically a question comes to your mind. That question also will be solved and will be resolved. That is what. A picture is worth more than 1,000 words. That is a very well-known saying. Similarly, a video is worth more than 1,000 pictures. Especially this visualization of mathematical concepts is a critical important skill in developing mathematical understanding in particular engineering mathematics. Basically, the main problem with engineering mathematics is we are not supposed to use rigorous mathematical concepts. Without using much theoretical mathematical concepts, we have to explain everything to the students. That is a very, very difficult task. The job of engineering mathematics teacher is more tough than the teacher who teaches engineering mathematics, because he has to explain so many things without using much advanced mathematical ideas. In our days, probably maybe 20, 30 days, 30 years back, people used to say how to learn mathematics. Practice the question, solve more number of questions, n number of times, then automatically you will get mathematics. That was the saying in olden days. That is absolutely a wrong statement nowadays. It has no way works out for now. So that is an outdated one only. So that is, practice is required. I don't say that it is not required. Practice is required. Much practice is not required if you understand properly. That is not what I mean to say. No need of doing 100 number of problems. It is enough if you say only 10 problems. If you properly understand that those 10 also different varieties. So here, this, for understanding any concept, these three are very important. Bhasha, that is what language. So mathematics is a language. One has to understand what that language tells you. The main reason for students feeling difficult mathematics is this. Once the teacher writes some mathematical equation on the board, they are unable to understand what it is. So because of not having proper language, knowledge in language, they are unable to understand mathematics. That is, bhasha is required. And simultaneously bhavam, the concept is also required. Language, concept, and also visualization. Bhasha, bhavam, and drishyam. All the three are important for understanding this mathematical language. So I think all of you are seeing this COW. Simply by looking at that COW, almost everybody who is seeing that, there is one picture is coming to their minds, a white body, 4 legs, 1 tail, and which gives milk, so much of things they are coming to their mind. But if the same thing is shown to a very, very from LKG boy who is just learning alphabets, he will simply pronounce it as COW. He never get the idea that it is a cow. So he knows only the letters. He doesn't know what actually it is. He never saw, but even if he saw the cow, he doesn't know that these two are same. So this combination is very much required. Now I will try to present you how some mathematical visualizations can be viewed. Some basic things I'll give you, and after that some advanced things what you are learning into it. This is what a product, 1 plus x square into 1 plus y square plus y cube. So this product everyone knows. Okay, this if I give this problem to any student, he will within no time they will give this product. But if I ask you what actually it tells you, what is, how do you visualize it? What actually, how can you apply this? If this is the question, then probably many students cannot answer that. They know math. Do you say that they don't know math? Yes, they know mathematics. What do you mean by mathematics? Simply multiplication of these three theoretical things only they know, but they don't know how to apply these things. Suppose you have 2 pens or 2 pencils and 3 mouses are there. So if I ask you to take the mouses and pens as you like, this 1 plus x square relates to this pencil. Somebody else may not take any pencil at all. One person may take only 1 pencil or maximum 2 pencils. Here similarly the case with 3 mouses. Somebody may not take any mouse at all. That is 1. Mouse y power 0. This is y power 1. He may take only 1 mouse. 2 mouses somebody can take. 3 mouses somebody can take. If I multiply these two, somebody may come without taking anything. He may go back. That means that is 1 into 1. Nothing he has taken. What is this 1 into y cube? 1 into y cube means somebody has come and he has taken all the mouses. That is another way. What is x square into y cube? X square into y cube takes you that he will take all 2 pencils as well as all the 3 mouses. That is the different ways how one can take these pencils and mouses that gives that product. If I ask select these objects as per your wish, if I ask you, then observe that the 12 terms what we get in this product are correspond to the number of ways of those selections. Yeah. So one interesting thing, composite function, all of you know. It's a very elementary high school level example. One thing I have given. Now we have come to some say functions we learned in your say maybe 10th class or intermediate, and there one concept called composite of functions. If I have one question like if I have one function say fx is equal to some 3x. If I put x is equal to what is f of fx? F of fx means once I find 3x and in place of 3x I will put 1, again in place of x I will 3x, I will go on doing it. If I take fx is equal to something like x square plus 5, what is f of x? If I put fx is x square plus 5, in this again put x square plus 5 in place of x, you will get f of x. Again do it. If I ask you to do it many times, what happens? That means a starting point, if I put x is equal to say 1, for example, in one function here in this, I will get 1 plus 5, 6. That 6 I have to substitute in the other function, that is what f of 6. What is f of 6? F of 6 is 36 plus 5, that is 41. Again put x is equal to 41 like this. What happens? If I ask you that question, how do you understand this thing? That means here if I put x is equal to 1, I am getting y value 6. After putting that x, that means this y is becoming x again and you are getting 41. Again this 41 is taking, you are substituting in the function, therefore this y is again becoming x. The main idea in this is the y is becoming x. How to make y to x? That is only important thing. If you understand that, that will be much more easy. Suppose you have here some curve is here. Suppose x is equal to some value a I substituted. Then this is your f of a. So this point is a comma fa. Now this fa is your y coordinate. That fa you will have on the x-axis also somewhere else. Where it will be? That if you identify, remaining thing is easy for you. Now I how to make this f of a, which is a y coordinate, to x coordinate. Now this is the line what we have, that is what we call it as y is equal to x line. So this point, if I draw a projection on that line, that perpendicular, now on this line y is always constant. Here y is fa, therefore at this point also y value is fa. Because it is a line y is equal to x, this point is fa comma fa. Again if I draw the perpendicular here, this is my f of a. Now corresponding to this f of a, it will cut the curve at some point. This is f of a comma f of a. Like that you will get the things. This is what the visualization of that repeated application of the same function. See here, this is one function 2x, another function is 2x into 1 minus x. Both have started at 0. If I substitute here at 0.1, sorry, this is 0.1. If I start at 0.1, this is 0.02. If I put here, if I start at 0.1 and if I all the values what I get, if I substitute again in those functions, then if x is 0.1, f of x is 2 into 0.1 is or 0.01 of course, 0.01 is 0.02. That 0.02 again multiplied to, that is 0.04. 0.04 multiplied by that, if you observe, these values are increasing. Whereas here, the same 0.01, if I substitute here, I'll get this value again, that is substituted in G, and if you observe, the values are coming closer to this. So f of x, if you do it very closely, do they converge or do they expand? Generally, general feeling of the students is, if I substitute one function into the other one, automatically it will go away. That is a general opinion what many students will have, but it doesn't happen always. So that you can observe here. So you have, this is the function y is equal to 2x. You started here at 0.1, and I think this cursor, I think everyone is seeing here. This is my 0.2. I have taken a projection on the line y is equal to x. This is my 0.2 and this is my 0.4. Like that, if I do it, it is going to infinity. Whereas fx is equal to 2x into x into 1 minus 1, 2x into 1 minus x. If I expand it, it is something like minus 2x square plus 2x, which is a parabola. And if I start here, the values will come closer and they will converge to this point. So if whatever you take continuously composite function, they will may converge or diverge without substituting in it. If you have the graphical idea, you can say for the same function, if you start at this point after 1, for example, if you start at 1.1, it will go away. You need not substitute in that function and you need not calculate all the things. If you have a geometrical idea about it, if you know this picture, if you know how to calculate function of a function using graphs, if you know this visualization, wherever you start, based on it, you can say that it goes to infinity or it goes to some finite value. If you start at 0.1, it is reaching, say, here 1 or 0.1, 0.5. But if I start more than 0.5, if I start at 0.06, if I do the same procedure, then it will go up to infinity. So this is what the similar kind of examples, of course. So another example is continuity of the function. All of you know what is a continuous function. Limit as extent, left hand limit and right hand limit should be same. If you see the left hand limit for this function, then you will get r. The right hand side of this function is 2r square minus 1. These two are equal. When 2r square minus 1 equal to r, for those values of r, it is continuous. Therefore, clearly it says that this function is continuous for some values of r and discontinuous for another values of r. So based on that r, so if you observe here, this is the red one is the left hand limit, right one is the left hand limit and right hand limit. At this point, both of them are coinciding, and after that they are deviating, and again both of them are touching each other at 1. Again it is continuous. So the function is continuous for different values of r, discontinuous at different values of r, continuous for different, continuous at this point say minus 1, continuous at the point say 1. Those are the, this is the visualization of that concept of continuity. In continuity, there are several kinds of concepts like continuity of first kind, continuity of second kind, what are the differences, how you removable the continuity, and all those things are there. Those things can also be applied using visualization. It can be understood using visualization. And inverse of a function. Every one of you know that it is inverse of a function. If a function is given to you, how to find the inverse of that function? Mathematically, everyone knows. I am not objecting you that I am not saying that you don't know what is inverse of a function. Suppose if you have one function y is equal to x cube, then what is inverse of a function? Everyone says it is x is equal to cube root y, or it is cube root of x. F inverse of x is cube root of x. In this way, they will give the answer. But what actually it means? See here, you have one function 2 power x. So see that 2 power x is this, and this is logarithm of 2 power. If you observe, the 2 power x and log x to base 2 are one is the inverse of the other. If you observe, the 2 power x image with reference to the line y is equal to x is inverse function. If you want to find the, if you are given a function, some graph is given to you, mathematical expression of that function is not given, some graph is given to you, that graph is this, the red colored one graph is given, this blue one is not given to you, but I want the inverse of this function, then simply take the image of that function with respect to the line y is equal to x, whatever graph you get, that is the inverse of the function. If your base is 1 by 2, that those the same function but with different values of base, it is 1 by 2 here. By the way, logarithms are there. The main advantage of logarithms, can any one of you tell me? You are using very extensively in curve fitting. Suppose if you are asked to in curve fitting, I think all of you have some x and y data they will give, and fit a curve of the form y is equal to a into b power x. And they will, in the question they will ask by fit a curve of the form y is equal to a into b power x by the principle of least squares. That is another thing they will say. So what actually is this? Principle of least squares, generally if you have some data, if you want to fit a line from this point, different points are there, see the distances from those points to this line, sum of the squares of the distances should be minimum. That is what a principle of least square, generally the normal equations will be derived for a line, but here there is one curve. How the curve in principle of least square can be applied for a curve? While explaining the principle of least square, we talk about a line, how to relate those two. This logarithms is a, I think all of you know some transformations, for Laplace transforms, Fourier transforms, jet transforms, like that several kinds of transformations you learned. This logarithms is also a transformation. So transformation is nothing but a function. A function is a transformation. So this logarithm is a transformation. What it transforms? For this, for example, if I take logarithm both sides, log y is equal to log a plus x log b. This log b is one constant, log a is one constant, a plus bx, log y is another constant y. That means the original xy plane is transformed to another x capital Y plane. On capital Y line, you are taking the logarithm values of this y. So logarithms converts a curve to a line. That is this is the y is equal to a b power x. So if you convert, this is becoming a line. This is another curve, and logarithms is converting a curve to a line. This is what transformation. Dealing with lines is easy than dealing with curves. That is why the transformation is transforming the curves to this. If even change of variables in multiple integration also will move from one domain to another domain where the shape of the region will change. Conveniently, we are changing the transformation. Transformations are very, very excellent concepts in mathematics. Logarithm is to be learned as a transformation. Okay. Anyway, next derivative and what you got, points of inflection and all those things. We talk about so many mathematical concepts. What is derivative? For example, if I ask you, I have given you one function, say some function what I have given you, but I am asking you to draw the graph of its derivative. Draw the graph of its derivative. How to draw the graph of the derivative? If function is given, I am not giving you the derivative from the function only. For that function, if you want to find the derivative, suppose it's a something difficult problem. Suppose x square plus 5 plus tan x by x plus 7 whole power 4. Suppose this kind of function is given to you. and I want the graph of the derivative. How to do these things? See, this red colored one is the function given to you. I want the graph of this function. How to draw the graph of the function? So, for drawing the graph of the function, you need to know so many characteristics of the derivative of the function. So, if you observe, this function is increasing here. After that, it has maximum. After that, it has minimum. It is decreasing, again increasing. So, if I try to draw the graph of the function, because it is increasing, derivative is positive. The graph of the derivative will be above the x-axis. After that, it has to come down. So it should come down to the negative side of the x-axis. Again, it has to go up. And at these points, it should cut the x-axis, because here f dash x is 0. At the maximum and minimum values, f dash x is 0. So those things you can observe here. See, from above some curve is coming there. It is there on the positive side. It is there on the positive side, and here it is derivative is becoming 0. If you observe the graph of the derivative exactly touched the x-axis, f dash x is 0. Now it is decreasing. Curve is decreasing means derivative is negative. Therefore, the graph of the derivative is coming down on the negative side. Again, it has come to 0, and after that it goes to positive side. One interesting thing is here, if you see the graph of the derivative, here the derivative graph is becoming 0. F dash x has minimum value. That means the second derivative is 0. Second derivative is 0 means the curve is converting from concavity to convexity. All those things can be explained to these graphs. You can understand very easily all those concepts if you see these kind of visualizations. And so many times we talk about the convergence. Is the time of 4:30? Okay. So I will skip this one. One important things I'll say. So these kind of expansions you will understand. You will come across this kind of examples so many ways. Let us see what example. Anywhere if you take any Taylor's expansion, all the Taylor's expansion gives the right side you will have one polynomials, left side you will have one function. So any Taylor's expansion or Maclaurin's expansion, whatever you take, they will give the polynomial approximations. Polynomial approximations of functions. Those are all polynomial approximations of those functions. So because all these are Maclaurin series, at x is equal to 0, for example, if you take e power x, what is the y value? Y is fx, y is equal to e power x. This is the curve. Then 0, 1 is the point. At 0, 1, can you tell me the equation of the tangent to y is equal to e power x? Y minus y1 is equal to, if I find the slope for it, e power x derivative is e power x only. If I put x is equal to 0, slope is 1. Y minus y1 is equal to slope into x minus 0. If I solve it, I'll get y is equal to x plus 1. You see that in that expansion, the first two terms are that. That means if a function is given to you, that function is approximated as a line at a point which is nothing but the tangent. After that, if you take one more term extra, you have a parabola. That means e power x and this parabola, both of them will coincide up to some extent. And if you take and one more term on the right side, this is a cubic function. That cubic polynomial and e power x will coincide up to some extent. This is what actually the Taylor's expansion is. You just observe here, the e power x is that blue colored curve. Red one is the right side expansion. First one is y is equal to 1. If you observe, a horizontal line will be there. y equal to 1 coming to the starting here. Again, if you see, yeah, this is y equal to 1. Next y equal to 1 plus x. Next parabola, cubic, fourth degree. So the terms are, the curves are close, coinciding each other up to some extent. After that, variation is there. Again, coincide up to, if I take more 5 terms, 7th terms this coincide. From 8th term onwards, they will variate. So that is what approximation means. You can have the better understanding of that probably from this. See here, we say sin x is equal, this is the curve sin x. If I expand it, this is the line y is equal to x. That means this line and the sine curve, both of them coincide each other to very closed interval about 0. Not exactly at 0. Around 0, both of them will coincide. That is what sin x, that is why we say that sin x is equal to x when x is same. If I take the other expansion for sin x, x minus x cube by 3 factorial, if you observe, the blue one is the graph of x minus x cube by 3 factorial. The red one is graph of sin x. Both of them are coinciding up to some extent. After that, they have a variation. If I take one more term, now the two graphs are coinciding each other in more larger interval. So like that, if you take more and more terms on the right side, the coincidence of the polynomial with the original function will be more. So the sin x and that graph both have coincide up to this extent. That means you have taken in a larger extent, in the larger interval, you can take sin x as this polynomial. So this is what actually the Fourier series, the Taylor series or Maclaurin series means. Coming to the topic eigenvalues and eigenvectors, every one of you know about these eigenvalues and eigenvectors. Once you have an eigenvalue, and generally question will be find the eigenvalues and eigenvectors of a matrix. And that is the questions are like that. The textbooks are also writing like that. The eigenvalues and eigenvectors, actually for a linear transformation we need to find the eigenvalues and eigenvectors. It's better not to write it as find the eigenvalues and eigenvectors as a matrix. At least write find the eigenvalues and eigenvectors of the transformation y is equal to ax, where a equal to that. That is much more better way. So here, for example, there is one transformation. One practical example I will give you. Assume that you have one bundle of white papers. This is the bundle. That bundle height is this. Okay. And you have pushed that bundle forward. The height will not change, only they will move forward. Suppose on the before the transformation, you just take one point here and another point here. If you join that with a thread, let us join these 2 points prior to the transformation. After the transformation, what happens? This point will move to this point, and this point also will also move to somewhere else, so that these two will change. So like that you have this. So here, if you move, there is one angle is phi. You can find out cot phi. Cot phi is y by this length, xx dash length. Where is it? Here, this length is xx dash, this is y, cot phi is xx dash by y. So xx dash is your y into cot phi. That cot phi I am calling it as ky. Therefore, if you transform it, then the things what you get is new coordinates will be x dash is equal to x plus ky, y dash is equal to y. This is the transformation. If you make it into x dash is equal to ax form, this is the transformation. This is the matrix what you will get. For this matrix, if you find the eigenvalues, this is one eigenvalue and this is one eigenvector. What is eigenvector? 1, 0, I bar comma 0 into j bar, that is I bar only is the eigenvector here. See here, the red color it is shown that direction is not changed. So eigenvectors are those vectors which do not change their direction prior and after the transformation. If some vectors do not change their direction, magnitude may change. The change in the magnitude is the eigenvalue. In that way, you can understand that. So I will show you directly the one important figure. See this figure. So this is after transformation. Prior to the transformation, it is like a square. On that square, you can see several colored arrows. After the transformation, observe the arrows. Some arrows are not changing their direction, whereas some arrows are changing their direction. The arrows which do not change their direction are the eigenvalues. For example, if you see this one, blue one, it is not changing. See the direction of the red colored ones, they are downwards, but after the transformation, the downward has come to slant height, therefore these are not the eigenvectors, these are the eigenvectors. Eigenvectors are those vectors which do not change their direction prior and after the transformation. So circle of curvature, center of curvature and all those concepts you know. So what is circle of curvature? If you take some curve, probably in the intermediate, I think, or maybe in first year of BTech, I don't know where it is, all the students will do one practical in their physics laboratories. That is what called spirometer. In that spirometer experiment, if you know that, they will give one kind of a lens, maybe convex or concave lens, and there you will find out the radius of curvature for it. What does it mean? That lens, what is given to you, it has been cut from a sphere. From which sphere of what radius it has been cut? That is the question for that. In fact, finding radius of the sphere, where radius of curvature means from what sphere that lens has been cut and what is the radius of that sphere, that experiment what you have done. Similarly, here in 2 dimensions, you are asking what is the radius of a circle, radius of curvature means if you are given a curve and from what part of the circle that curve has been cut. That is the question. Finding radius of curvature means if you take different parts of the curve, you will get different radius of curvature. One observation is at the minimum or maximum values of the function, you will have the radius of curvature minimum. I think all of you know it is 1 plus y1 square whole power 3 by 2 by y2. That is the formula for it. So this is the formula what you have, 1 plus y1 square whole power 3 by 2 into y2, that is the formula for radius of curvature. And this you have y1 square here. If y1 becomes 0, you will have some value. If y1 is other value, then something you are adding to the numerator. Therefore, the minimum value will be attained at y1 is equal to 0. y1 is 0 means first derivative is 0. When first derivative becomes 0, those points are maximum and minimum point. That is why the circle radius will be minimum at the maximum point and minimum point. So similarly, you have one thing called length of the arc. If you want to find the length of a curve, the crude method is join the starting point and end point, find this length. That length and the curve arc length, the length of the curve, both are not exactly same. Definitely there will be some error. Lot more error will be there. That is a crude method. But if I take one more point on the curve, if I join these two line segments, then you will get a better approximation. Like that, if you similarly add more and more number of points on the curve, and if you add those line segments, ultimately whatever you get is equal to the length of the curve. Therefore, to find the length of the curve, we need to add the length of the line segments. We need to add the length of the line segments. That is what dl is the line segment length, which is equal to dx square plus dy square, and we will integrate because we are add that. This is the formula for finding the length of the curve. So idea is for finding the length of the curve, we are adding the different line segments. As many line segments you take on the curve, so much of approximate value do you get. So you are adding this length, this length, this length, and this length. That is idea of finding the length of a curve. I think in differential equations you have some Newton's law of cooling. If you have one body which is kept at 30 degrees centigrade, room temperature is 20, after certain time it will come to the room temperature 20. This is the graph of that Newton's law of cooling. If you take a very cooling body and after that it will approach to the room temperature, that will increase, then you will, that K will be a positive value. So I'll give this. So this is orthogonal trajectories, and I'll give you the about the Fourier series. Probably this is much more interesting for you. All of you will know how to find the Fourier series of a function fx is equal to x by 2 in minus pi and pi. So this is the Fourier series what you get. What actually it means? Right side you have sine functions, left side some algebraic function. How an algebraic function will become a trigonometric function? The answer to that is this. X by 2 in one interval. In different intervals the same x by 2 is, that is what periodicity. Periodic function. And this is the sine function. Those two will coincide. If you see, observe here is on the right side originally sine x. If you right side sine x, sine cube x by 3, if I take, all these curves are simply coinciding with the line. This is what actually Fourier series tells you. The electrical engineers and also electronics engineers, this is what actually they need. Simply finding the Fourier series not enough. What actually it means, wherever you have a signal which has periodic nature, that can always be approximated is sines and cosines. A similar kind of, suppose this is the function what you give, and if you find the Fourier series, on the right side if you take several functions, they are coinciding with the given function. Half range Fourier sine and cosine series. So in half range series you will have a function 0 to 7, and for the same function you will find cosine series as well as sine series. That means you have to extend that series on the right side as well as on the left side. So here the function is extended on the negative side of the x-axis. That means I have taken a reflection about y-axis. Then it becomes an even function. Therefore, only cosine series exists for it. For 0, 7, if you extend it on the with respect to the origin, you are getting an odd function. Therefore, its Fourier series contains the sine terms. That is what the in half range sine series we do. So I think there are so many things are there. It's already 450. So this is something like change of order of integration, about triple integrals. You can see so many kinds of ideas. So key points in visualization definitely enhances your understanding of any mathematical concept. I have prepared some kind of animations for showing those results. You can have your own animations. This is not fixed. You can have your own animations as you like. In fact, this visualization gives you an excellent tool for understanding. For the benefit of the students, some online tools I have given here, Many Eyes, Swivel, Google Docs, and GeoGebra, Texas Instruments, and Maple. These are all the several tools with which you can make your own visualizations. So my one suggestion is, in your college, try to have one club with those similar some kind of people who have similar enthusiasm to prepare the visualizations. You can include some computer science students with electronics, electrical, mechanical, everybody. You just try to write a program. If even using Python, you can write so many programs for making your own visualizations. And you can take the help of this AI tools already developed now. If you give this question, give a visualization for so-and-so topic to an AI, I'm sure it will not give. If you want, you can check it. Even ChatGPT also, it will give some kind of pictures they will give, but not of this clarity. You have to write your own programs. That is always better to this. So before my conclusion of this lecture, generally this is what I try to give you one message to the students. That is what this is. Science discovers and technology follows. Whatever science invents, the technology automatically uses that science and they will follow that. So will that science and technology make us happy? So definitely science and technology will not make us happy. It will give us only comforts. If you want to go for a movie, no need of waiting in the line. From house itself, you can book a ticket. If you want to eat something from any particular restaurant, you can order for the food from that restaurant. Immediately you get the food and you can enjoy it. Those are the facilities. But even if you have so many facilities, you will not get any happiness. So happiness you will get only by some kind of things what you make to others. Like do some kind of help to others, whatever possible extent. Thereby you will get more happiness. Be happy and let others also live very happily. I'll be more happy if you ask any questions on the topic.
Thank you, sir. Thank you, Dr. M.A. Srinivas, sir, for your nice lecture on visualization of a mathematical concept. This is the time for question and answer session. The participants who are interested to clarify his or her doubts, please come forward to post it only in the Q&A box.
Srinivas sir.
Yeah, please.
Sir, really valuable lecture, sir.
Thank you.
The approach of visualizing basic mathematical concepts through practical example is highly effective, sir. It has sparked an interest in mathematics among BTech students, and also it gives a significant opportunity to enhance their thinking abilities, sir. Really wonderful, sir.
Yeah, thank you very much.
Yes, sir.
In fact, I thought of, because the audience are BTech students.
Yes, sir.
I don't want to give a lecture on some topic
mainly related to first
interest.
and second BTech, sir. So this is very useful lecture for BTech first year, sir.
Who are the participants?
Yes, sir.
Yes. That's the reason why I have chosen this generalized topic.
Yes, sir.
Yeah.
Once again, I request the participants, please post your queries in the Q&A box. Sir, I have checked so far, no questions are posted. So
Okay.
I'm going ahead.
If they don't
Thank
post
you.
any question, something to say. So in Vedas it was said like this: Anantaparam kila sabda sastram svalpam tadairvahitam yadhartam saram tato grahyam apasya palgu hamso yatha kshira mivambu madhyat. Meaning is, the Sabda Shastram, that is the science of words. In other way, we can take it as some knowledge. The knowledge is Anantaparam. This is vast, very endless. But Svalpam tad Ayur Vahitam. Ayush is very, very short. So because it is very short, our life is very short and knowledge is very vast, we have to gain more knowledge. To gain more knowledge, we have to remove certain things, unnecessary things. Remove as much as possible which is not relevant to you, irrelevant to you. Leave them, irrelevant things, leave it. And try to extract most useful knowledge. by discarding other rest of the things, just like as swan do the things like it will separate milk and water. So nowadays most of you are concentrating on these mobiles and all, and so many distractions are there. Forget about those distractions. Before going to bed, ask yourself, what is the knowledge I gained today? That knowledge may not be related to the academics. It may be in general also. What is the knowledge I gained today? If your answer is 0 continuously for 10 to 15 days, you need to change. Even if you ask that question yourself, automatically you will change. డెఫినెట్గా మారుతారు. ఈ క్వశ్చన్ వేసి పడుకోండి 10-15 రోజులకి, మీరే మనం ఏం నేర్చుకోవట్లేదు, టైం వేస్ట్ అవుతుందని, యూ విల్ స్టార్ట్ లెర్నింగ్ ద థింగ్స్. వన్స్ యూ కమ్ ఇన్ టు ద రైట్ ట్రాక్, డెఫినెట్లీ యూ విల్ సీ highest positions in your life. I wish you all the best.
Sir?
Thank you, sir.
Sir.
Yeah.
Sir, if you don't mind, please open your video, sir, because we will take a snapshot for filing purpose, sir. Please.
Sure. Because of this constraint of probably just
yes, sir.
a minute.
Just only few seconds, sir. We will take a snapshot for the purpose of filing.
Is it okay now?
Oh. Balai sir, please carry on the program, sir.
Yes, sir.
Yeah.
Thank you one and all for your good response and valuable support. Expecting the same cooperation for the remaining sessions also. Today's session concludes with vote of thanks by staff organizer Sri I. Pothraju, sir. Good evening to all. On behalf of the Department of Mathematics and the participants, I would like to express my heartfelt thanks to our today's resource person, Dr. M.A. Srinivas Garu, Professor Emeritus, Department of Mathematics, JNTU College of Engineering, Science and Technology, Hyderabad, who gave such a good and informative presentation on visualization of mathematical concepts. Despite of his busy work schedule, he gladly accepted our invitation and gave a valuable talk in today's session. Thank you very much, sir. I would like to thank our beloved head of the department and convener of this international workshop, Dr. KVLN Acharyulu sir, who guided, motivated and supported us to do this program and encouraged us to shape out today's program. I would like to thank our principal sir and our management, Babla Education Society, for providing us all the facilities and encouraging us to conduct this program. Without their support, it would not be possible to conduct such a program today. I would like to thank to Dr. K. Mandip, Department of CSE, Institutions Innovation Council, IIC members, Sri M. Lenin Babu, Faculty of EC Department, Sri S. Prabhudas, Faculty of IT Department, Sri Srikant Nalluri, Faculty of CSE Department, Sri A. Kishore, Sai Kishore and Sri U. Venugopal, who are sincerely extending their technical support to us in conducting this international workshop. Thank you one and all.
Sir, thank you, sir. Kindly extend the same cooperation.
Thank you, sir.
For our future endeavors also, sir.
Sure, definitely. So we are all academicians. Whatever academic work it is there, then we need to attend for it. And we feel happy if we interact. If the students interact more, it will be much more better way. But they are unable to interact with that. But probably if it is a physical interaction, probably they'll come forward to interact. But online,
so we are also planning, sir. We will contact you very soon, sir.
Yeah, no problem. That's fine. Thank you.
All
All the
participants.
best to all of you. I think I can leave now.
Okay, sir. Thank you, sir.
Can I sign up? Yeah.
Yes, sir.
Thank you, sir.
I think you have taken the snaps.
Yes, sir.
Yes, sir.
Thank you. Bye.
All participants are requested to fill up the feedback form, which is shared in chat box and will be shared in WhatsApp groups also. Thank you, sir. Sir, can we conclude, sir?
Okay, bye, sir.
Sir,
Okay, sir.
I am ending the session, sir. Thank you.
Okay, thank you.